actually work with Chef or Puppet? Fair amount. Okay, how many people actually work with Docker? Same amount. Okay, there we go. All right, well, good. The idea of this session was, so when I spent a lot of time over the last year, I always think I have 4 jobs, right? One is my family, which is a great job. The second job is my day job, right? Which is, today, and I'll tell you, I work at Docker, right? So, and in fact, good time to tell you who I am. John Willis, Director of Ecosystem Development, Docker, which means that I'm in BD. I try to help partners integrate with Docker in the ecosystem, so anybody who's trying to figure out how to, use Docker, take advantage of Docker, that kind of stuff. I try to help them. I've got a team of 3 guys that we help them integrate. So that's kind of my second job. My third job is really, I've been an evangelist for many years. Some of you know me, and I like to pick themes throughout a certain period. And one of the themes this year has been immutable infrastructure. And I'm going to talk a little bit about my thoughts about that. And then, near the end of last year, and my fourth job is this thing called DevOps, which is I spent a lot of time thinking about lean, thinking about like the meta layer of why DevOps is awesome, not the tools. And if all things being equal, if I could do that full time, that's what I would do. I would just join a think tank and really think about how to create organizational capital. So, with all that, I started thinking about what kind of presentation would I do at scale that could be valuable giving, except for my family. Actually, my family, because my son spoke yesterday, so actually all 4 things. How could I give a presentation that might take all that into account? And kind of the driver was the unikernel thing. So when we acquired a unikernel company a while back, and it's been killing me not to say anything about it. I mean, good friend. I have a friend I'm gonna mention later, Gareth Rushgrove. He's like, I was in London. He's like, you got to come up and meet the guys from Cambridge. I'm like, yeah, that'd be cool. The Cambridge guys are the guys that are like, I couldn't say anything to them. It was so hard. So I thought, okay, how do I put this all in perspective? Like, how do I put immutable infrastructure? How do I take my experiences of what I've done with Chef and Puppet and put that in a presentation? I kind of, called it Devopsing the operating system, really, which is, how have we dealt with this thing within the last at least 10 years, certain, but maybe 15 years, from 2000 on. So for those who don't know who I am, I pretty much live through Twitter in terms of my communication. I try to use that as my primary vehicle for communication. If you want to get a hold of me afterwards, if you want to yell at me, tell me I'm an idiot, whatever. If you want more feedback on some of the things I mentioned, that's really always the best place to get me. That is Dr. Deming, that's not me. I do a podcast with one of my best friends, Damon Edwards. I've been doing this for an awfully long time, 35 years in IT operations. I actually was early in at Canonical when they were just first starting their private cloud, like 2009. And then I was the 9th person in at Chef Ops Code. Helped kind of define the customer-facing business there. The startup gods, that is to say, I spent 30 years of failed startups, but the last 3 to 4 years, I'd say 4 years now, have been very good to me because I've had 2 exits. I had one in strategy sold to Dell, and a year, basically next month, it'll be a year, I sold a company called Socket Plane to Docker, where we did like SDN stuff. I'm a core organizer for DevOps. So again, for the people who don't know me, I'm not bragging. I want you to get a perspective of why maybe this presentation will make sense. I was at the first original DevOps days in Ghent. I was the only American there. I've been part of that whole system, helped create the first DevOps days in the US and DevOps days. And then I also work a lot with Gene Kim. How many people have heard of Gene Kim? Right? If you haven't, and I don't make any money off of this, although all transparency, I will indirectly make money, and you'll see why in the next slide. But he wrote a book called The Phoenix Project. And if you're interested in kind of the meta layer of DevOps, you should read that book. It's a novel. You'll read it and you'll say, in fact, remember when I tell you this, that you will say this, because when you say it, you'll say, hey, that dopey guy said I would say this. You'll say, how did Gene get into my company? How did he sneak in and figure out what was going on in my company? And to that, we just finished a book. This is kind of my last shameless plug. we figured it's the book called the DevOps Handbook. Jez Humble, Gene, and Patrick. We've been working on it for 4 years. It's been rewritten about 3 times. It's finally done. I mean, it is like done this week. And it really, it's not because I've written it. I mean, if you've ever read anything by Jez Humble or Gene, it will be the most comprehensive book on DevOps. And I've read pretty much every one. And again, I'm not just saying it's because it's mine, or partially mine. But the last thing I'll say, because I'm going to try to get into the rest of the presentation, is going to be kind of this operating system, more tooly discussion. But like I said, my kind of fourth job is that meta layer about DevOps. And there's been a lot of definitions about DevOps over the years. And Adam Jacob, the founder of OpsCode, for years to me held the prominent definition, which was DevOps is a professional and cultural movement, full stop. We're done. Nothing more to say. As I've been really working hard on the last 3 months of kind of completing this book, I've been going through chapter and chapter and rewriting stuff, and I realized that, you know, I kind of have my own definition now that I think is the one I like best, which is DevOps is a movement motivated to turn human capital into high-performance organizational capital. There's a lot there, and things that we're doing with Gene with the DevOps survey. We've categorized statistically high-performing organizations. How do you train people? It's the beauty. To me, it's a beautiful sentence because it explains it's not just humans and it's not just tools. The tools are the glue between organizational capital and human capital. Okay. How many people have ever seen this screen? Yeah. So let's go back with the Wayback Machine, right? You know, back in the late 90s, maybe early 2000s, as I get old, my memory gets a little hazy, but you know, most enterprises, I did a lot of Tivoli consulting, actually, before I got into kind of cloud and open source and Chef and things like that, Puppet. I did a bunch of work with large enterprises doing Tivoli work, and most large enterprises, most banks and insurance companies were predominantly Windows-based for most of their core service applications. There were a few examples, like in design and things like that. Sure, you had Sun and other type of, but a lot of the business of America was basically, a lot was Windows and very little Linux. In fact, I remember it was about 2002 where the guy from Bank of America told me that Linux will never be in production, and he told me flat out, Linux will never be in production at Bank of America. And so anyway, so the idea was, for the people who haven't used this, basically it was called Ghost, and you basically took pictures of an operating system, you saved it, and people would do their rollouts of desktops and servers on this model of a ghost imaging. And basically they'd have an image, and a lot of people would do some cadence, maybe like quarterly, have quarterly builds, and then they would, early on, they would just script the deltas. So you'd have a quarterly ghost build image, and then before the next quarter, anything that got added or had to get slammed in between that quarter, hey, we got a new version of this and this has to go in, or this new tool has to be in there. You'd script the deltas and then you'd start over. And the problem with this was, for anybody who lived it, like we had no management systems for cataloging images. We didn't even know we had to do that. and the chaos that happened was wrong images got, like where's the right image? You could have whole weekend rollouts. Plus the technology to build the systems sometimes took a whole weekend. Like if you had 3,000 servers, in fact some banks it was, they called it the painting a bridge syndrome. You literally rolled out and then you finish painting the bridge, you actually start over to go back again, right? And what happened then, we really, somewhere along the way, you know, give or take, we had this kind of what I call first generation configuration management. And if you look at, like, you know, there was Tivoli, there was Blade Logic, there was Opsware, there was some others. Those are what I used to call the big three. And if you look on the right, that's actually a Tivoli for installing an AIX package. And if, for those of you who've used Chef or Puppet, it kind of looks the same a little bit, right? And in fact, as you go back and you look at like the Tivoli configurator, I refreshed my memory and went back to look at the manual. It's kind of interesting how many of the primitives were almost the same, right? But here's the key thing is this was not a convergent or did not adhere to some of the desired state concepts that we use with what I'll call talk about in a second, is second generation configuration management. And that is, everything was kind of individually defined. Now, some were smart enough to say, I'm going to do this is order, but you never thought of a system as a desired state or systems like this is the web server 404. This is the proxy server, or this is, you basically built, like you had this blob and you built it up like this. So it was never a holistic view. And again, it didn't have convergence. It was very transactional. You did things like install commit, remove kit. You had pre-install, post-install scripts. So there's a lot of cool things. I mean, I made a lot of money. You know, I got my first boat from Tivoli, right? Like, so, you know, but it wasn't right. I mean, it was, you know, it was a mess. I mean, literally, there were companies that literally were doing the painting the bridge installation of infrastructure. And then, I think it was 2007, I go to OSCON. So I did this, I was doing a bunch of Tivoli stuff. I sold my business to my business partner. And I figured, all right, I'll just do open source stuff because I don't have a non-compete on that stuff. And I show up at OSCON, and I'm really interested in Nagios versus Tivoli monitoring. Like, this is what, like, I really want to. And I go to this session called Puppet because somebody told me it was a monitoring tool. So I sit in there in the back row, and I see this young kid, you know, I'm going to exaggerate here, but he had pimples, he probably didn't, Luke Canese, and the founder of Puppet Labs. And he's talking about configuration management, and I'm like in the back row thinking, what is this young kid going to tell? I just left Bank of America, and 10 minutes in, I'm in the front row, and I realize my life is changing. Because what he's talking about is like so much better than everything I've done for the last 10 years. And so I get to meet him about a month later in Nashville, and I do an interview with him. And he tells me about this system, these guys in Seattle. And this is 2007, right? So there's this, one of the early applications on Facebook called iLike. Went in 1 week, so they figured, hey, let's do this thing on Facebook. Let's create an application. Went from 500,000 users to 6 million users in 1 week. Turns out there was some consultant in Seattle that basically enabled him to do that because there was no cloud. They did it with bare metal. They went from 500,000 customers to 6 million customers in 1 week in bare metal. And so I wrote this blog article. I'm like, this is like, why do people spend $3 million on Tivoli? And when they can hire a couple consultants and use things like Cobbler and Kickstart and Puppet, and they were all using Puppet. And it turned out to be Adam Jacob, who's the founder of Chef, Absolute Chef. So he pings me. We become friends. Long story short, I wind up going to work for him. But this one more thing before that. The guy who came in as the CEO of Chef. Around the same time, Jesse Robbins wrote this really cool, it's still out there, it's called Operations and Competitive Advantage, The Secret Sauce. He actually subtitled it Tale to Startups. At the time, most people would think in a traditional operations model would basically, in a left-hand graph, they'd say, okay, I'm going to be a startup, I'm probably going to have, in the first 8 weeks, maybe 20 servers, and, 12 weeks, right? I'm going to have 20 servers, and so how am I going to dedicate, how am I going to build this? So a traditional would be, minus technical debt, right? We would go ahead and just kind of build everything we had and then learn as we grow and build stuff. And what he tried to show is, was that if you really paid the technical debt, particularly in dealing with the building of the operating system. And when I say the operating system, I'm using it loosely, right? I think you realize that now. I'm building what it takes to build infrastructure. And what he was saying is that if you spend a lot of time in that first couple of weeks building out the infrastructure in a certain repeatable way, and he was at Amazon at the time, and they were using a modified version of CF Engine, so I've been told, and then he showed graphically what could happen in terms of your ongoing costs. And in fact, early on in the days when we started talking about these type of models, we would say things like, what do you think your server to sysadmin ratio was? And you could go into the kind of Tivoli shops, which I did, the BMC and Blade Logic shop, and they would tell you 1 to 30, 1 to 50. And in the early days of companies that what I would call second generation configuration management, really starting with Luke. Now CF Engine was 20 years old last year. And I'll talk about it in a second, but with Luke, Luke really put this kind of infrastructure as code, desired state configuration management on the map. And I'll explain that in a minute. But what we saw then is those ratios started going up to like 1 to 500, 1 to 700, you know, like in some of the web scale companies. And today, it's actually not uncommon to be 1 to 30,000. And that's pre-container and unikernel, right? But what happened here, just for those who don't know the history, 21 years ago, Mark Burgess is a professor at University of Oslo, inherits the data center to manage. Like, who else should manage? Yeah, the guy who teaches computer science, of course. And he realizes that the, I'll try to only curse once in this presentation, and I'm going to lie, so I'll probably do it 2 or 3, but he realizes that all the current tools are shite that actually use it, and so he creates a student project to figure out how to do this right, and they start designing things like desired state, configuration management, convergence, this idea that you actually treat the machine as a state. It's the web server, and I want it to be tamed like a web server. So I have an agent that constantly looks. And what's interesting is Luke Knies was actually kind of a power consultant of CF Engine. And he got frustrated because Mark is a good friend of mine now. Mark was in academia, and he didn't give a rip about the interface. It was all XML. It was horrible. And anytime a user would say, "Can you like, why can't you make this interface easier?" And he'd like, "Not my problem. I teach computer science." And the big guys like Amazon and Facebook and all those guys, they didn't care because they put a human capital, if you will, into the problem to make it better for them. If you went to a large company like Facebook and said, "Do you run CF Engine?" they'd say, "Yeah, kinda." Like we put like so many hours into CF Engine in our development that it really isn't CF Engine anymore. Well, so Luke got frustrated and he wrote the whole thing over again in Puppet, or in his language, in Ruby, in a language that he provided as a DSL called Puppet. And then and the story kind of continues where Adam Jacob was, like you saw it, he was doing those ILIKE and large-scale infrastructure with Puppet, and he felt there were some things missing, and the cloud was just coming along, and Puppet was very nested deep in enterprise, Red Hat enterprise, and all of a sudden, you know, cloud, Ubuntu, and all this becomes and it just little things like Chef. For those who have used Chef, like Chef Knife was a great example. Chef Knife was almost a year ahead of Puppet in terms of being able to just type in a command and provision seamlessly an Amazon instance with no human interaction. Right? It would basically catch the exit, come back, get the information back that the instance was started, get the instance ID, turn around, and start provisioning configuration. So you had this kind of what I call second generation configuration manager, and that's just a Chef recipe there. And I thought I'd put this in as I transition, because again, I'm trying to walk through this, you know, what have we done over the last 15 years, what have we done right, what have we done wrong. You know, I did, at the DevOps Enterprise Summit, I did a Docker for Managers, and I tried to go back, and I saw lots of people do the history of virtualization. Lots of people do history of cloud, and then one of the things we'll talk about a little bit with Docker in a little bit is their kind of image copy on write model for imaging. And I realized nobody really put one of all of them together. So at least as accurate as Wikipedia is and as accurate as my 56-year-old memory is, this is the history of pretty much all the things we've seen. It's kind of interesting, things like, you know, whenever I go back and look at this, like, I think its zones were, I always think they were, Solaris zones were like in the 60s, you know? And then I look at that and say, it was actually really as late as 2004. But the story really changed, right, in 2006. Right, Amazon, cloud instances, all that stuff. And again, I think you saw a lot of ops code was able to take advantage of, you know, the ability to do this. You know, what Adam was doing seamlessly with ILIKE, with things like Kickstart and Cobbler, and then kicking off Puppet, you were able to basically drive. The good stuff's coming, guys. Anyway, and then and it's funny. And we said with the Ghost stuff, right? We had like image sprawl. Then everything kind of calmed down, and then we got into cloud, and it happened all over again. Like, there's a message here that we make the same mistakes over and over and over again. So all of a sudden, around 2009, a friend of mine, Randy Bias, writes this blog article, and he's absolutely right, is that we had the same image sprawl problem all over again that we had with ghost imaging. And in fact, one of the greatest stories was PBS actually, so there's a tool, it's still used quite prominently, called RightScale. And it was a tool that basically abstracts and allows you to manage multiple clouds, and primarily Amazon. And I'm sure they fixed this now, but at the time, there was a checkbox to say whether you wanted to be a public image or a private image. And the default was public. And unfortunately, PBS actually put a private image public and had all the keys in it. And it took them 3 days to clean up that mess, right? And again, we had like, if you read the article, there was just images. I mean, even today, really, it's still not really easy to find the right image for the right. I mean, it is because you got the elastic and stuff like that. But the point is, it's still a problem. And so what really drove Chef and Puppet at that point was, yeah, that is a problem. That's why you want infrastructure as code, right? Infrastructure as code, you kind of get your best case just enough operating system, and then we build everything through a library or a DSL-defined infrastructure. We have cookbooks for everything. We put, I'm more familiar with Chef terminology. I've worked with Puppet, fair enough, but we create a run list, and we kind of catalog that as the web server. And then it runs these cookbooks, which runs these recipes that from the kickoff of however you're instantiating, either it's through clouding it with Amazon, and then you start firing off these cookbooks, i.e. recipes, and you start building the infrastructure incremental. And life's great, right? Because everything's in GitHub, and you got, you load it, you know where it looks like, you hit a button, you should look the same. And Adam wrote a chapter in, if you haven't read Web Operations, it's an excellent book, John Osbar. He wrote chapter 5 where he jokingly talks about, watching a movie, tornado hits your data center, you put the movie on pause. I mean, it's a little flippant. You go ahead and you reload your infrastructure as code in, you kill your cloud service, turn it off, you unpause, you put down your popcorn, now you pick the popcorn up, you unpause the movie, right? But I mean, that's how we've lived for quite a while now, except somewhere along the way, and I remember when I was at OpsCode, Netflix wrote this article called Building with Legos. And I'm like, oh no, here we go again. Image sprawl, all the things that don't we as humans ever learn, right? But what was interesting is it was a head fake. Yes, they were building AMI images as golden images, like our two early examples, ghosting and all that. But what they did cleverly is they were actually building like they were building WAR files. So the whole concept of jar of war, they just took that to the whole infrastructure. So what they did is they'd actually, and this whole discussion came up called bake versus fry. Do you bake an image or do you fry an image? And a bake is holistic, it's built, right? There's advantages in when you start it up, it starts up for the most part. If you have to fry it like infrastructure code, you got to work your way up. Could be 8, 10, 15 minutes. I've heard companies tell me 30 minutes. They're saying, oh no, we bake them. But what we do is we bake them just like we bake application code. We put it in Nexus or Artifactory or wherever they put it. And when you go to provision, you pull the latest release. And then of course there's some services they built to build the scaffolding for convergence between multiple systems, clusters and all that. But in the end it was like, oh wow, this is nice. And actually this was really the birth of really, even though they didn't call it at the time immutable infrastructure, this was really the birth of a concept of immutable infrastructure, where you had this concept of immutability, and let me say immutability as in the terms of a metaphor, not exactly immutable, because no computer system is immutable. Things change the minute you turn it on, but immutability in terms of the sense that somebody could take a system and throw it into some provision and be assured that for the most part the bits are the same for the important parts. And that if you need to change it, you just re-provisioned it. Or you rolled back to the earliest release. And this has worked for Netflix, reasonably successful, although they've had to put, like everybody else who does this really well, a lot of human capital into making this work. Because if you go out and look in their open source projects, right, there's like a trend amount of code that they've written, even on Amazon, where that was the whole point. You had to go to Amazon, you didn't have to have a whole group to build all this infrastructure. And so, I'm sure everybody in this room knows this, because I'm going to transition now into kind of immutability and containers. And of course I'm going to talk about Docker, but just to make sure we're all on the same page, and we certainly are, right? There's really, what pre-unikernel, we think about the kind of 3 types of virtualization that we that we deal with on a day-to-day. We got type 1, our VMware ESX, hypervised APV. Indirectly, that's Amazon rack space, although I know some of those guys have converted to KVM at some point. But in general, what we saw over the last, at least most of the time over the last 10 years have been Xen-based. And then type 2, right, which is our KVM, VirtualBox, VMware Workstation, and certainly indirectly Vagrant, right, for everybody who's using Vagrant either on VirtualBox or, and then we saw with Docker the rise of what was called OS level virtualization, right, which is this is hypervisor-less virtualization. The compute is really Linux processes. OpenVC was a good example, actually, and Docker was really an abstraction on top of LXC with some other cool stuff. And this is a really good slide from an IBM paper that came out about a year and a half ago, kind of depicting the difference between a type 1, type 2, and Linux containers. When people ask what's the big deal about a container, well, it may or may not be a big deal, but you're type 1, right? You have the hardware, you have the hypervisor, and then you have the VMs, and the VMs contain everything, the operating system. It's a full stack, right? These are big, fat images. And then your type 2 is your hardware operating system, and then the hypervisor is on top of the operating system, and then from there it's really the same concept. And then where OS level virtualization, the predominant model for that is, or implementation of that is Linux containers. You have the hardware operating system, and then you share the operating system kernel, and then the images are reasonably small compared to big VMDKs or large AMIs. And so what you get with the OS level virtualization is you get millisecond provisioning, right? So you can provision a container in 400, 500 milliseconds, depending on how much is in it and all that kind of good stuff, right? There's some as low as 150, 200 milliseconds. I guess 240 milliseconds is probably the shortest I've seen. It is bare metal performance, so you don't have the hypervisor getting in the way of the, you don't have the queuing, all the things in the hypervisor. There's some value at scale of that. It is, for the most part, VM-like, right? I mean, for most of the things that you see people using today and what you can use, most applications, I mean, name a few, I mean, MySQL, Nginx, I mean, we can spit them out. They all run in containers pretty well. Every once in a while, there's some idiosyncrasies that we have to do certain things a little bit differently. But for the most part, it satisfies most of our requirements for running what we call virtualization. It's lightweight, and of course, there's a rising tide lifts all boats in that there's been a lot of people contributing. The viral growth numbers on Docker are, I think that in October, they had their billionth download for Docker Hub. So that's 2.5 years, right? Like, and I mean, this isn't an apples to apples comparison, but I can't remember how long it took Facebook to get to 1 billion users. And it isn't an apples and apples, but I'm just saying 1 billion downloads is pretty crazy. And here's the crazy thing. In January, I remember that we were bragging, it was April, our CEO did a blog post where he was bragging about our growth, and it was basically 500 million. So we had, in our first 2 years, we went from 0 to 5 million, and then in the next 6 months, we went to 1 billion. That's a hockey stick. So if you're not building containers, I mean, you basically, each root file system is called a container. You share the kernel. You get isolation of the process. We use namespaces. So you build namespace isolation. Actually, 191 and now 110, which is in release candidate 1 right now, is actually added a user namespace. So now you actually be root in the namespace, but not on the host. And that solves a lot of it. The 110 is a really significant security release. I mean, really significant. SE cop support, everything there. And then, since most of people knew Docker here, I won't spend too much time here, but it's a thing. What I want to transition into, the thing I think that's become really interesting is immutable infrastructure, and how some people are starting to deliver infrastructure in the way like the Netflix building with Legos concept, but even crazier, if you will. And it's because of this isolation. And one of the things that containers, so one of the things that happen with containers, and again, my preferred container dialogue is going to be Docker. Of course, there are others, and pick your favorite. But the thing is, developers love containers, and I'll just say developers love Docker. And the reason developers love Docker, there's a lot of reasons. One is, imagine, you're a developer, your last line of code, something makes a mistake, you're testing, and you got to rebuild your infrastructure. And it's a converged service, so it has your part of 5 or 6 different services. You probably can't run that on your laptop, maybe. But even if you could, the spin up of that service on a good day could be 3-5 minutes, could be 12 minutes. And I remember, I told you I did a DevOps Cafe podcast, and I remember we interviewed a lot of people, and what I'd heard over and over was from developer managers would say that our developers actually get mad, because the ones that transition to Docker, they get mad if their infrastructure doesn't converge in like 2 seconds. You're talking about spoiled, right? Prior it was 5-8 minutes, right? So there's this idea that you can spin everything up really quick, build your environment. The fact that you can actually run your whole environment on your laptop, so if there's 4 or 5 other services that are owned by 4 or 5 other groups, you can load them all into your VirtualBox infrastructure, test yours against it, and here's the part that gets really exciting, is everything there is basically immutable. So that means that everything that I do, when I'm done with my infrastructure for my service, and I've basically pulled the great latest, almost think about the Netflix model where everything's loaded into an artifact factory or some place where it is immutable at that point. Everybody else is, at least at this release, is immutable. I test my service, I ship it off, and we'll talk about integration here in a second because that gets even more exciting. But for the most part, for me as a developer, I'm pretty safe in knowing that as it goes through the pipeline, integration, CD, and in production, the bits I tested here are the same bits I tested there. And and we say in DevOps, developers should wear pagers, right? Imagine you wear pages, and you pretty much can know really quick whether it's your code or something else, because at least you now know a lot of the edge cases are going to be so insane. More than likely, it's going to be an infrastructure problem, or it's going to be their code problem. It's going to be easier to figure out, right? So this immutability thing has really driven. It's not for everybody. It's not for all applications. I tell people, don't go home and tell your manager that we need to throw out all this legacy that we've had the last 40 years and turn it into immutable infrastructure, right? But greenfield, new microservice terminal architectures. This is a predominant model that's getting a lot of success. We talked about the lightweight. Again, Docker just made it simple. Linux containers been around forever. Docker just made it really brain dead simple. I had my own experience 3.5 years ago. A good friend of mine wrote a book called Test-Driven Development Chef, and he talked about using containers in a CI, how to do scale-out CI testing with containers. Imagine you create a Postgres table and get to that same table state 1,000 times in integration test without having to fire up 1,000 VMs. Test it, fire up the next VM. Test it, fire up the next VM. 2, 3 minutes, 4 minutes per VM, right? Take days. Imagine you could do that in 400 milliseconds, right? An hour. So you could do these scale out tests. The thing he didn't ever really explain how to do it, and I tried to figure out how to do it, and I gave up. And then the first time I got a chance to get to an early copy of Docker when it was still Docker Cloud, I read the README, and literally I had a container up in 7 minutes. In fact, my first run, I thought it didn't work. I said, anybody's run the Docker run. I said Docker run, Ubuntu or Docker run. I figured what one of the base images, and it just ran, did nothing. I'm like, it didn't work again. It did work, it just didn't tell it to do anything. And then we talked about community and all that. So, and then Microsoft, that same paper I showed you earlier, they did this thing about where they tested, they did some benchmarking. And so that's the paper, the same paper that had that diagram I had earlier. What they did is they did a serial string of 150 Apache servers with just simple web servers. Very simple, nothing to it, but they spun them off serially, 150 in, it was 36 seconds. So, and the teardown time was 9 seconds. Right, so start thinking about the speed and immutability, start thinking about different types of workloads that where the compute probably is going to have a shorter TTL, right? The time to live, and anyway, so this is just a little more of the architecture of Docker I took from the training in case you hadn't seen Docker, but you got basically Docker engine runs as a daemon that interfaces with these processes that are encapsulated by namespaces and all that stuff, and allows it to interact with the operating system kernel on the physical layer. And then I figured I'd throw this in on the client architecture. Does everybody understand how the Docker host and Docker containers work in general? Yeah. Anybody done? Okay. Okay. All right. But another important point of this model, so you have containers and then you have containers, right? And one of the clever things that the Docker people did, because I've only been a Docker a year, so I take no credit for any of this, is well, it's just minus containers, right? Yeah, but the other thing I did, if you go back to one of the things I put in that timeline earlier, which was some of the things that came out like ButterFS. I don't have AUFS there, but this idea of these copy on write file systems, and what was cool is this opened up. I think it has a lot to do with capital L lot to do with Docker success, in that it used these copy on write file systems, what they call union file systems, out of the box. And the idea of a union file system is everything's layered. So you're always instituting a layer on the thing, and you inherit the previous layers. And the top layer is the writable layer. So for those of you who work with a Docker container, you run a container against an image. That image is kind of a binary of everything's been stored, immutable. And then when you fire it up, if you go in and start installing packages or making directories, that's all going to be in the copy on write layer. And then if you don't commit that image, or commit that container, you lose all that, right? And we'll talk about Docker files in a minute, and how you can do an alternate way to do that. But the bottom line is that's basically kind of a memory copy of what you have. Now, why is that awesome? One is you can create immutable infrastructure that contains everything. The application, any of the middleware, all the things that you need are encapsulated. By the way, I didn't mention this earlier, if you didn't know that when you instantiate Docker, it can run on bare metal, it can run on private virtualizations and KVM, it can run on Amazon, it can run on GC, it basically can run anywhere, right? And immutable, because it doesn't care. I mean, the only thing it really cares about is the sharing of the operating system, so you might want to be consistent there, but in general, if it's running Ubuntu on bare metal 14.04 and it's running Ubuntu 14.04 on GCE or Amazon, for the most part, Docker doesn't give a rip, right? But here's the thing, so you have this image thing with the copy on write, so you got the immutability, which is awesome. But think about what is the other killer thing of why people like Docker? Is because you can do these insane things in your CI loop testing. And one of the reasons you can do that is because of that copy on write layer. I think it's the next slide. No, I got a minute, but there's a great Gartner article about, imagine if the testing state of a table, you got a Postgres table, you want to test that state, then you want to crush it and start back at that state again. You want to do that testing 1,000 different variations, right? If all you had to do is rebase the memory, like the image is already layered, it's already on wherever your infrastructure is, probably your laptop, or maybe it's in some Jenkins slave that's running a Docker inside a VM, and all you have to do is basically set the image level back to the original. So now you're talking probably less than 100 milliseconds. We're not even loading up the whole thing now, we're just basically instantiating back a layer image lower and starting over. So you get into some really, really cool scenarios where you see people telling stories of doing these crazy web scale horizontal testing in CI that really couldn't happen. And so to dive back to the operating system discussion, what you basically do, how many people have built images from a Docker file? A little less, but that's the same. So this is the Ubuntu. This is actually the current 14.04 Docker file for Ubuntu. One of the things we have is this thing called Scratch, right? And Scratch is basically it's an image defined that is nothing really. It's kind of a base plate for building layering. You can't do a pull Scratch and you can't do a Docker run scratch. But it's how you can start. It sets up the foundation for building, for kind of creating a container with nothing. And so this example where we actually pull, if you actually go to Ubuntu, right, that's the same image you would do to create an AMI if you were starting from scratch. You would create, you know, for Trusty in 1404, you would pull the cold cloud image. So, and if it doesn't know, when you do an add against a tar GZ, it just basically untars it, and that becomes the directory structure. So you just laid down across of nothing the instantiation of a cloud image, and then they just customize the init and stuff like that, because containers don't really have init inherently, and then ultimately bash. So in a sense, all your Ubuntus are, you know, when you talk about like Ubuntu, you're really kind of some modified version of Ubuntu is based on the cloud image. I mean, you can just, if you go to Docker Hub, you can select any Docker file. So you can look at CentOS or Fedora and all that. Now, some of them you have to see. You got to go back to the source code of when they built the image, like the CentOS one. It's just a kind of a Docker.tar file for CentOS that gets pushed over and built. So we have these things called webhooks. Well, not we have. There are webhooks and implementations so that you can put in your GitHub repository a file to say every time we change this or do we do a commit, go ahead and, you know, rebuild and point it at the Docker Hub, create your image. And these actually have to be what they call official images. And then there's, you know, how many people have heard of BusyBox? Now I'm testing. So the numbers keep going down. Yeah, so BusyBox was developed early on as this kind of, I mean, we wouldn't call it, you know, so I don't think there's a phrase called just enough container, but like just enough operating system. It really was a really minimalistic operating system. Early days of Docker, it was used heavily for training. It was used for, you know, just kind of, you know, you'd certainly use it for verification processes if you wanted. In fact, I think the Docker getting started, you run a hello world, and it basically runs BusyBox, right? But here's the cool thing, and this starts getting into the world of you know, where we are and where we're going, unikernels, is that a lot of people will take BusyBox as a base to start thinking about very small app-centric container images. There's been some really good ones where Java. So the other words is, notice I'm not loading the cloud image from Ubuntu, right? Or, well, you don't see anything here, but if you look in there, I'm not loading anything from, when I do this model, I'm going to take this base image where they've just put the basics in, and then I'm going to go ahead and I'm really only going to put, it's really an operating system-less operating system, right? And what I'm going to do is I'm going to start adding only the things I need. And I'll show you an example. We did this with, so my startup was Socket Plane. We required you to run Open vSwitch. So we had, what we built is an SDN for Docker. And so what we wanted to do is ship with our install a container that had Open vSwitch in it. So Open vSwitch is the most popular open source virtual switching fabric. And we went ahead and used the BusyBox implementation. So we kind of made our own little Socket Plane one because we had a couple tweaks there. But in general, we added just the things that were required. I didn't do this, Dave Tucker did this, where he reverse engineered Open vSwitch and found out only the things that you needed for Open vSwitch. So we had and we weren't doing it for, we'll talk about unikernels in a minute, we weren't doing it for all the kind of things that are making unikernels complicated right now. We did it because we wanted to make it as small as freaking possible. Because we knew it was going to be something that somebody had to add as part of the installation of our product. It had to be there, and we wanted to make it like as tight as possible, and we wanted to make the image as small as possible. So that's what we did. But that, again, you saw a lot between 2012 and 2015, a lot of people who would do these type of, you know, all right, let's just roll up our sleeves and figure out what this application needs. It's going to be this layer of Java instrumentation, need this kind of libraries, and when it's done, and in a sense, it had a lot of the properties of a unikernel. It wasn't a unikernel, right? Because it still ran as OS level virtualization. They run it under a true host, and I'll talk about unikernels in a minute. So it wasn't a unikernel, but it was very special purpose. So there was this kind of special purpose, you know, and I don't really want to call them operating systems, right? And I just wanted to mention that for those who don't know that, the top part's been around for a while, the Azure, but a Windows Server 2016, Microsoft has actually written their own container implementation that is 100% Docker API compatible. So basically, out of the box, you will basically have Docker run, Docker pull, Docker push. The image stuff is still not as fluent as, because they're not as going to have as many images, and there's still some work to be done on how to run Docker files and builds of images, given the licensing constraints, but other things too. But in general, all the things that you know about Docker run, Docker, all the primitives of the Docker command will basically be sorted, and you will be able to create images. And in fact, Microsoft has even gone as far as creating the nano servers, right? So the joke is they took the Windows out of a Windows operating system, right? And then I talked about immutable infrastructure. I talked about the Legos. Martin Fowler wrote Immutable Infrastructure. Let's see, what am I at? I'm at 45 minutes. I probably need to go a little fast to get to the... I'm going to skip this. I have links to all my immutable discussions. This is an important paper, and it proves basically from really a true computer science, Steve Turgot, of why you want to do immutable infrastructure. And I've done many presentations on this, and you read it and you get a sense of what's the difference between a congruent versus convergent versus, and a congruent basically is going to be an immutable infrastructure, and I've written some articles. And, so I want to get into unikernels because we got a few minutes left, right? So that's all the buzz, right? So for those who don't know unikernels, and I'm not a unikernels expert, it was thrown on my lap like everybody else. With, for some of you might have been working on it for years, but I think most of us are like, oh God, what's this now? Now I got to explain this one to my boss. So unikernels are specialized virtual machines. So we saw this happening with the containers and the special purpose, this was building up, right? And I would tell people in their infrastructure, I'd if you want to do this right, really go ahead and have an infrastructure, not even talking about unikernels. If you're going to use Docker, get an infrastructure group that builds base images for your organization. This whole thing about and do your own vulnerability. I know we're doing some stuff with Nautilus, and you can follow that project for vulnerability scanning, but own your infrastructure. So actually you're going to do this at scale. Start having people that think about don't let people pull images from the wild. We don't let people pull good hygiene chef shops. Don't let people pull chef cookbooks from the wild. They vet them, they infrastructure. No, they're supposed to. I saw some snarky faces, but I say that with containers. Roll up your sleeves, figure out what the base images are for your organization, build those, make those as your. If it's this is the base Java image that you get for containers. And if you need something more, let's put in a request and let's create it that way. So unikernels are like taking it on steroids, where you're basically going to get a language to take the parts, all the parts, and you basically build an image that really is the kernel. There's no concept of user space, kernel space. It's just all kernel space. Again, I'm not an expert here, but if you think, oh my God, that's the worst thing that could ever happen, you would say, well, think of Erlang. It has that kind of model of Erlang where it's designed for failure. Mileage varies definitely on the type of unikernel, but the idea is that what you're taking that concept I was describing with containers to its furthest point. We are actually now going to basically develop images that just strip out everything. And you can see, well, I have some slides on the benefits here, and obviously I'm sure everybody knows this now. We acquired unikernel systems, were the ones that do Mirage OS. They were doing some of the most significant work with unikernels out of Cambridge. They were here all week. They're the guys that were teaching most of the class. There are the unikernels. And then just to put it in perspective, right, so we went over this. We got our type 1 hypervisor. We'd run a VM with the full stack on top of it. If we're running containers, we're running a host. We could run bare metal host with the container and application in the container, the image. Or what most people do today, unless you're really, really scale and you've invested human capital, people run containers in virtualization environments because of the isolation. And so you pretty much run a VM, and then you either throw a whole bunch of containers in it, or in some cases, the Guilt story, they run they actually run an Amazon image per container. So they get like a T1 small. I forget what they get. They get a real small image, and they're microservices based. And now what we're going to see now is this weird thing where like everything's gone, right? Like now we just have the hypervisor and this unikernel out, and that has been compiled. And I'm getting some weird faces who probably have never heard of unikernels, like they want to come up and choke me. But we'll talk about why you might want to do that in a couple of minutes. But imagine this too. There's always upside, downside. Like anytime new technology comes out, like it sounds awesome. It's not binary, right? There's risk reward, but some of the upsides of this, there's plenty of downside. I'm not going to blow smoke up anybody's ass, but some of the upside is this idea now people can do actually just-in-time compile of an application. You know, before we had this static image, whether we were using big VMDKs or even if we were using Docker with the host image. And then we thought we were doing just in time with the application because we could take what's in Git, we file, run it, bang, and we could do 1,000 deploys a day, or we can do, you know, Amazon blows to one point, they did 1,000 deploys in 1 hour, right? And we talk about just, you know, people developing infrastructure really fast. Imagine that, like, all that underbelly stuff is also just in time, right? It gets pretty crazy, right? And this is a good paper. Any blog article you start reading about unikernels, it kind of points back, hey, you probably should read this paper before you read my blog. And it goes into like the history, more than you want to know. Anyway, just get a sense. I'm not going to go through it in gory detail, but you're basically going through this compile process, and then you're creating this image. What's there, you know, lots of vulnerabilities. There certainly are other unikernels other than Mirage. This is some, they all have some form of a language that they use to build, because remember, this is a scenario where everything is compiled. You're not pulling somebody else's base of something and then only building on top of it. You are building the whole thing that is a VM now, but not a VM in the traditional sense of like a VMware or Zen. It is a VM in the sense that the hypervisor is going to launch this thing, and there is no operating system in theory. Of course, most of the testing and development is going to happen under a VM right now, but in theory, you have a bare metal machine, you have a type 1 hypervisor, and you run unikernel VMs, which was the previous slide. And then the rump kernel is another one that should be looked at. You know, very interesting stuff there, what these guys done. And so, you know, why unikernels? Why is everybody going nuts over unikernels right now? I mean, you know, clearly the performance is interesting, right? We go from 400 or 500 milliseconds to under 100 milliseconds. Okay, you know, will that be significant? Maybe. I mean, I think the place where you might want to think about significance of that is if anybody's done anything with Amazon Lambda, and if you've seen some success in those, in certain workflow or certain patterns of work. That's where this will make a difference. The ability to instantiate something as if it is so ephemeral that it doesn't, like, the fact that it started and stopped is almost equal to the time of the application. The instantiating times memory for, but a lot of people are getting really interested. And I think unikernels are gonna, you know, it's like anything else. We, you know, as humans, we bought pet rocks. And everybody's gonna be running around about unikernels now for the 6 months about, my God, stop everything. And I'm not one of those guys. I love new technology, but I love it for technology's sake. But there's some truth and there's some non-truth in this. The truth is that we are fighting a horrible battle with people who figure out who could get into our systems and attack us and understand our patterns. When your system is completely compiled, there's no known footprint of directory structure. There's no utilities. So as an attack, you basically decrease the attack vector off the chart, right? Because you can't, like, I can go into any variant of a Debian system and I can figure out things as an attacker. I'm not an attacker, but and I wouldn't know the first thing about what the attackers do, other than that they screw me up sometimes. But the fact that they can identify, or they can found this, or they can right? Like, Verizon, this always blows me away. Josh Corman told me this. 2015 Verizon report, basically 97% of every compromise, so they have a pretty vast summary that they do, or survey, 97% of every compromise was due to 10 known CVEs. If you don't know what CVE is, it's in this database, National Institute of Technology, to document all. They tell you, here's the one that really kills you. Not just the 97 were down, well down to 10. 8 of them were over 10 years old. This is why people are going to get really excited. This is why your boss is probably going to come from some Gartner seminar and scream at you why we aren't running unikernels. Because they're going to hear this like there's no... Starting points for a balance. Gareth is amazing, works for Puppet. He's been involved with unikernels very early on. He's been with Docker very early on. I wish he worked for Docker and not Puppet, but but he gives you the good and the bad. I love his quote. Part of the, he's saying somewhere along the way, why are people going crazy at numbers? He says, part of this is a numbers game. To run a reasonable system, you might need 50 different services and 200 packages, and an attacker has to compromise just one of these to win, right? But he does the counterbalance. He said, I got another blog article about security and what he thinks, and again, it's not all, it's not binary, it's not black and white, and but here's some examples of like now we're talking about, again, on speed and performance, right? A DNS server that's 446 kilobytes, right? It's a web server, no vSwitch speed. I mean, this will make a difference, right? Things that start up in less than 100 milliseconds that are at this size that I can run. Early days of what Netflix was doing with Amazon in terms of auto scaling and infrastructure, none of those three are even close to that level of what some of these like really good implementations of auto scaling infrastructure and true orchestration modeling of infrastructure. We're working on it, and unikernels is going to be even worse, right? Years now, 5 years now, is rethink networking. That's why we got sold to Docker, because we thought we had it, at least for Docker. It's going to be 5 times as hard for unikernels. Debugging, the next slide will make you laugh, but anybody can guess what the next slide is. I will send you something really cool in the mail. It's a hard one. What? No, it's on the tip. Right, and but on the upside, I said opportunities. Opportunities says like things that we can make better, even though they're bad now. Forcing the immutable. If you like an immutable architecture, this is your baby. Like you're not changing anything, right? You can't. Like there's no tools. Like we don't put them in there. There's no utilities. So all the bad things that you can't debug, those are all the good things because you can't get in and change anything. So if you like immutability, you're a win. This was the slide I was hoping somebody would guess. Brian Cantrell. I love Brian Cantrell. I think he's the funniest guy on the planet. I think he's one of the smartest guys I've ever met. He's actually a very personally nice guy. He does rant a little bit. So I don't know when it was, sometime this week, he went off chart about unikernels. But here's the thing, I read it, and he's right. But the things he's going to lay out, and that's the main thing. There's a whole bunch of things he's going to say that he's going to have to take back in a year from now when Joyent goes in. Hi, Brian, if you're watching, because he did the same thing with Docker.
when Docker first came out, he ranted about how Docker was so horrible and it was going to destroy it. He never was against containers, but he thought Docker was not ready for prime time, couldn't. And in a sense, he was right. A year later, Joint implemented into their infrastructure. In a year from now, I guarantee you that Joint will have a form of Docker's unikernel implemented into Joint. But he's a brilliant man, and read this article, because I'm not going to blow smoke up here and tell you unikernels are the best things ever. Brian is like 10 times smarter than I'll ever be. And his one statement that reigns absolute truth is something we're all going to have to deal with if we want to use unikernels is, unikernels in capital are entirely undebuggable. There's a list of things you're not going to get. So thank you very much.